Hey folks, here's Mr. Elting. We're going to be talking about special case factoring today. If you wouldn't mind, turn to page 8 in your factoring workbook. If you don't have a factoring workbook, you're going to have to write this on a scrap sheet of paper. Pause the video at this time to make that happen. Now, when I say special case factoring, really the only thing that we're going to be focusing on today is just a quick little shortcut. This shortcut works for things called uh, difference of squares. Remember that'll come up later, but this is all based on perfect squares. And so my first question for you is, do you know what a perfect square is? If your answer is yes, which hopefully it is, a perfect square is just a number that can be obtained through multiplying a smaller number by itself. So for example, 16 is a perfect square because it is equal to one of its factors, 4, times itself. 4 times 4 is 16, so 16 is a perfect number. Another way to think about this is 16 is a perfect square because it is equal to a number squared. 4 squared is 16, so 16 is a perfect square number. Now, I want you to list all the numbers between 1 and 100 in your workbook. A good way to do this is just start with the lowest number of all. 1 squared is 1. There's your first perfect square. 2 squared is 4. That's your second perfect square. 3 squared is 3 times 3, not 6, but 9. That is your third perfect square. Keep going with this until you get to at least 100. There's not nearly as many as you probably think there are going to be, but go ahead and see how many you get. If you got them all, you should have gotten the numbers 1, 4, 9, 16, 25, 36, 49, 64, 81, and lastly 100. And interestingly enough, there's 10 perfect squares between 1 and 100, and they happen to be 1 squared, 2 squared, 3 squared, 4 squared, all the way through 10 squared. Isn't that interesting? Now, why do I care about these numbers, and what do they have to do with these special case factoring problems? Well, I'd love to show you. If you take a look here at these problems, I will do the first one for you. You know how to do this. We're going to use the box method. Or, if you're really good at this, perhaps you know the shortcut by now. You can do these mentally. X times x, I know, is x squared. 3 times negative 3, I know, is going to give me minus 9. And then my middle terms, I'm going to get 3x and negative 3x. Oh, that's interesting. Negative 3x plus x is actually 0. I'm actually just left with x squared minus 9. If you want to see that in the box really quickly, x, 3, x, negative 3, x squared, negative 9, 3x, and negative 3x, then negative 3x, and 3x actually just cancel each other out, giving you x squared minus 9. I would like you to multiply these next two out on your own and see what you get. And please answer what you got for x squared, x plus 7 times x minus 7. You've done that well. Hopefully you got the following: x squared minus 25 and x squared minus 49. I think perhaps you might be detecting a pattern. There are no middle terms, and these numbers are all the perfect squares that we listed on the last page. Now, what does that have to do with factoring? Well, if we run into one of these guys, it means that we can instantly factor it. Let me give you a quick example. If I have a problem, here are the ones that you're going to do, but I'm going to make one up. Let's say I have x squared minus 49. Well, it should look awfully familiar, considering you just did this backwards, but you should already know that factors of 49 are 7 and 7. Factors of x squared are x and x. Because I have this negative 49, one will be positive and one will be negative. And this is correct because I'll end up getting positive 7x canceling with negative 7x, which gives me no middle term. So in other words, in order to factor things that look like this, you're just going to write x plus the square root of that number, x minus the square root of that number, x plus the square root of 36, x minus the square root of 36, or you could rearrange that. You could do x minus and then x plus, either order. But go ahead on your own, try these three, see if you can't figure it out in your workbook. If you got all three of these, then hopefully you ended up with x plus 6, x minus 6, x plus 8, x minus 8, x plus 10, x minus 10. Now, just to be clear, if you're like, oh, but I don't know how to square root things, there is a button in your calculator that does it for you, in case you don't have these memorized. It looks like this. It usually is accessed by doing second, and then there's usually an x squared button on your calculator. If you hit second x squared, it usually will pop up the square root. So you hit square root, second x squared, and you type in the number you want to square root, for example, 18, and then you would get an answer. The square root of 18, unfortunately, is like 2.3 something, something, something. It's not a whole number, unfortunately. All right, so what is the shortcut for factoring a difference of squares? Hopefully you got it by now. Write that down on your sheet for me. And the last question I have for you is, will it work for these two problems right here? Will it work for x squared minus 20? Will it work for x squared plus 25? Please, please, please pause the video if it doesn't stop and answer those two questions in your workbook, and then we'll come talk about it. All right, welcome back. Here's the answer. This first one is not factorable for the reason that 20 does not have a perfect square root. If I wanted to square root 20, I think I get 4 point something, but I think if you remember correctly, we don't really deal in decimal when we're factoring. So this is a no-go. In fact, this is prime. This one, you might be tempted to think that it's x plus 5 times x plus 5, but that is not right. 5 and 5 will give you 25, and the x and x will give you x squared. But don't forget that you would get 5x and 5x, so you should also have a 10x in between those two numbers. So why doesn't it work? Well, in order to get a difference of squares, keyword difference, this sign right here needs to always be a negative. All right, I think that's it, guys. Go ahead and continue on the web quest, and make sure you ask any questions if you have any. Thanks.